Hi, this is Katie Vukovic with CBB. I'm here with Tim Byers, a network engineer from CBB. We're here to talk to you about SD-WAN and Network as a Service and what that might mean to organizations that you serve. In the agenda, we'll introduce you to SD-WAN and Network as a Service, discuss Network as a Service, being a Cisco Meraki managed service offer, and also review SD-WAN, our VeloCloud offering. Tim?
Thanks, Katie, and thanks everyone for participating. Today's SD-WAN market is exploding, and you've surely heard about SD-WAN or soon to hear about SD-WAN if you're not already making plans. We're seeing that SD-WAN, along with other kinds of things as a service, so to speak, whether it's network or unified communications, is a tremendous growth potential for us and you and your customers. I'm going to explain, by way of introduction, where SD-WAN comes from, the problems that it seeks to solve, and the offers that we have here at CBB that will help you and your customers. When we think about networking, I think about the jobs that we hire a network to do. If we think of networks as we would employees, we hire them to do certain things for our organizations. And they're listed here. The important jobs of a network is, first of all, connectivity. Today's networks are a combination of connections between headquarters, data centers, remote branches. Oftentimes we have our private networks that are also connecting to public clouds as well. Job one is for our network to connect to each other. Job two is that once we have these connections established, our network needs to perform the way we need it to. Applications run our businesses, and that's not just data and accounting and finance applications. Today's networks also have to run real-time applications like voice and video and collaboration. So job number two is for our networks to perform well. The third job of a network is for it to be reliable. Gone are the days when networks didn't have to be up all the time. Like dial tone was, networks need to be always on. Our applications need to be always available. So our networks have to be reliable. And then none of these jobs makes any sense unless the fourth job is in place, and that's the job of security. As we connect our networks, especially to public clouds and public applications, we have to make sure that our networks are secure. And so we have traditionally seen organizations build networks in some fashion or another similar to what you're seeing here, where headquarters and data centers are connected to private networks using MPLS or other kinds of technologies and deploying physical layer services like fiber and copper to their branch locations. And these kind of networks are very secure, they're very predictable in terms of the bandwidth available, and they deliver the kind of performance that most customers need. But increasingly, applications and business environments have driven customers to move away from completely private networks to also deploy public networks, such as the internet. And so whether that's cable, DSL, or 4G for backup services, or even using VPN for primary network connections, public networks are now in the mix of many customers' environments. As well as you'll see illustrated here, a move not just from private data centers, but also to public services. So CBB, for example, offers a hosted telephony service. Customers who are deploying that are attaching those to their networks, and so they need to have access to these services with predictable performance and high degree of availability and security. So as we consider how networks are built, and we turn back to this metaphor of the job that we hire the network to do, we ask the question, how is our network doing? And when we look at the traditional network that's involved with private MPLS connections, we can see that in a lot of cases, these networks are expensive to build and maintain and difficult when it comes time to change or refresh them. There's a lot of touch points, there's a lot of lead time, there's a lot of project management, a lot of site visits. puts a big strain on corporate IT resources to manage these networks. It's often difficult for organizations who are looking at adding or subtracting new locations to be able to turn up those locations quickly and deliver the applications to those sites as needed. And then finally, underpinning all of these challenges is often, even though a network is in place and has a high degree of performance or security, it's often difficult to measure how it is doing. Do we know what users are doing? Do we know if the security policies are being followed? Do we preserve bandwidth for the right kinds of real-time applications like voice and video that we need to? So all of these questions and the challenges they present to IT organizations have really given rise to the SD-WAN industry. SD-WAN, in its simplest definition, stands for Software-Defined Wide Area Networking. And the key to it is the use of intelligence to provide control engines that allow multiple network types to be managed under a single console. So in other words, the idea is that using an SD-WAN technology allows you to bring whatever kind of connection you want, and the device finds the brain and configures the network the way you want it to. So as illustrated here, you can have a combination of private MPLS and public internet providing services to the variety of branch locations that you have, but SD-WAN manages and configures and gives visibility into all of those. And whether those are connections to private data centers or to public services like shown here, SD-WAN provides the opportunity to manage all of that under a kind of a single pane of glass. What gets really interesting in the SD-WAN space is that some providers are also taking a look at the applications running over these networks and are doing things to provide a higher quality of experience for those as well. Some vendors are deploying at the premise only. Others are also distributing their infrastructure in the cloud to provide these services, and I'll talk more about that as I transition to talk about the offers from CBB. SD-WAN promises the following kinds of benefits. First of all, by providing that single pane of glass management structure, it makes it simpler to deploy locations. You plug in, you install the infrastructure, you plug it into the network, the devices find each other, and then they form into a network of the design that you crafted in the centralized console. You have visibility into all the connections. You can have alerts, often traffic shaping and other kinds of mechanisms to make the network perform the way that you want it to. So it simplifies the administration of the network, which can help you reduce the time it takes to upgrade and deploy new sites. Most offers are what we say transport or bandwidth agnostic, which means you can bring whatever bandwidth, whatever services you have from the network and plug it into the device, and it can still form a cohesive network as you want. And it gives you the opportunity, as most vendors are doing and we're doing, is to be able to convert that kind of roller coaster of capital expenditure that comes with buying hardware, buying software, buying professional services, thinking about refreshes, and that kind of roller coaster of capital expense. It gives us the opportunity to convert that and provide that as an operating expense, a utility-based managed service that gives the organization a very high degree of financial predictability. So out there in the world, you'll find lots of vendors joining the SD-WAN landscape. And on this slide, I want to identify a few of the similarities and some of the differences that you'll find as you begin to evaluate the different vendors in this space. Most of the vendors are going to try to offer things like you'll see here on the left, in terms of most of them tend to be agnostic when it comes to the transport. Although some carriers are now starting to offer SD-WAN services bundled with their own transport, which in some cases can make you feel like you're locked in to picking their transport. But that's not a technical requirement of SD-WAN. It's more of a way that certain providers are delivering SD-WAN. All SD-WAN providers are going to do some flavor of auto VPN, which means you plug the gear into the internet, the boxes find each other, and you can use a centralized configuration method to deploy the kind of network that you want, hub and spoke, fully meshed, whatever. The centralized tool allows quicker provisioning of the devices, so not telnetting into devices and doing command line scripts, but more centralized web-based provisioning tools. And all of them are promising the potential to move away from these more expensive private connections and achieve savings using public connections. Where some things get really interesting is as you really start to drill down into the differences in some of the approaches that the vendors take. That's shown here on the right. For example, some vendors, in order to achieve redundancy, are going to require multiple WAN links. So for example, in order to really get the benefit of their SD-WAN technology, assume that you have a cable connection paired with a 4G connection, for example. Not every vendor, but some are going to assume that that's the way you're deploying their product. Some are doing redundancy based on simple up-down failover mechanisms. In other words, they're watching for a link to be up. If it's down, if it goes down, they'll switch traffic to the backup link. Other vendors are able to drill further into the application and do some mitigation repair on the session itself, and I'll talk about an approach there that we've chosen at CBB. Some of them assume that you are deploying gear on site, others are deployed in the cloud, and a few have a kind of a combination approach or a hybrid approach. And as I mentioned, also, not all of them are able to really understand the applications you're running through the network and are doing more link or session-based traffic failover. And the solution I'm going to talk about with our SD-WAN offer actually drills down into the real-time application like voice and video and has the ability to improve the quality of that experience. So that concludes the introduction part of the conversation about the general landscape of SD-WAN and where it comes from in the industry. What I'd like to do now is talk about the two offers that we have here at CBB and how they fit into the market. On the left is our offering called Network as a Service. That is a bundle of network infrastructure based on the Cisco Meraki line, and that involves a security appliance that sits at the edge of the network and plugs in the transport, whether that's private MPLS or public internet. It's a full-featured security device, a complete UTM stack with IDS, IPS, anti-malware, traffic shaping, application control, and that forms the core of the service. The service is also bundled with a 24-port PoE switch and a wireless access point so that customers can very easily deploy infrastructure in their branch locations. This deployment is geared for customers who really are seeking to refresh and create standards within the deployment of infrastructure in their branch. This is a CBB installed, managed, and maintained offer, delivered completely as an OpEx expense. And you see the price range there that is determined based on the size of throughput and the number of clients that you have at that branch. Network as a Service is the Cisco Meraki bundle. On the right side is our SD-WAN offer that uses VeloCloud. VeloCloud is similar to the Meraki MX appliance in that it's a security appliance and that it has connections for network transport there. It's also deployed the same way, installed, managed, and maintained by CBB, also delivered as an OpEx expense, just like Network as a Service. But the difference with VeloCloud is that it has a very sharp focus on quality experience for the real-time applications, which I'll explain in a while. But the key to both of these offers is that they both are fully installed, deployed, managed, and maintained by CBB and delivered as an OpEx. So this really both offers allow customers who are looking to transition from self-managed or expensive MPLS and take advantage of less expensive public services and still get the quality and visibility that they need with an SD-WAN deployment. Let me focus a little bit on VeloCloud, because VeloCloud is a very exciting service that we're offering, which we're calling SD-WAN. It uses a combination of premise-based edge devices and cloud-positioned gateways to keep an eye on these real-time applications. And so what happens is that in a typical deployment, you deploy an edge device at a branch, you plug the internet transport into it, you have applications at the branch such as hosted VoIP, where phones are registering to SIP cores, SIP hosted providers. And because of the way VeloCloud works, that edge gateway is looking for its counterpart in the network somewhere near the hosted SIP provider. And by pairing a gateway with an edge device, the VeloCloud unit can watch the performance of that VoIP traffic. And so as latency, jitter, or packet loss becomes problematic for that VoIP stream, VeloCloud will actually begin to duplicate packets over that link, and it can do this over a single link. It doesn't require redundant links, but it can do it over a single link, and by duplicating packets, it can, in the gateway nearest the hosted VoIP provider, assemble the best of the two streams that are running through the internet and deliver end-to-end a very high-quality experience, even if the quality of the connection in between is not so great. In fact, we have done our own internal testing as we were vetting out the different solutions that we were going to go forward with. And in our own testing, we introduced up to 40% packet loss inside of the internet and still had acceptable phone call quality go through. So we're excited and think that customers who are really interested in deploying cloud-based applications like VoIP and video will see a strong benefit by deploying VeloCloud in their environments. So that might raise the question in your mind, well, which fits which kind of customer? And so I've highlighted here a couple of the comparison and contrasting points between the two offers. And I guess what I would like to say is that in some cases, the customer may choose one offer over the other depending on what their need is. But we're seeing in our early deployments that in some cases, a customer might need both. And I'll try to explain that. So, of course, the ideal customer in both cases is considering SD-WAN. And as I mentioned at the beginning, if you haven't heard of SD-WAN, you very shortly will, and you will soon start to hear customers taking an interest in making plans to move in that direction and evaluate technology. So both fit the general umbrella of the SD-WAN term. Network as a service, the Meraki-based offer, is for folks who have a lot of sites and really need help with their total infrastructure. For example, they need a security appliance, but they might also need PoE switching, or they need wireless access points. Meraki has a great unified stack of tools to keep an eye on all of that, gives you great visibility into what users are doing in terms of their application. It has traffic shaping, so you can control social media versus real-time applications, and does a great job in that area. And we think that this platform is really strong for folks who have limited IT resources and need help with kind of the entire stack of infrastructure in their branches. Probably sites that have a lot of standardized deployments, retail, manufacturing, where the sites are kind of cookie cutter. We think that's going to be a good fit. VeloCloud, on the other hand, sharpens the focus for those who may be okay with their infrastructure, but really want to get help deploying their real-time applications like voice and video. So in some cases, VeloCloud might fit the bill and leave the rest of the infrastructure in place. But in other cases, a customer might want to replace both the network infrastructure and deploy VeloCloud for protection of the real-time application and have both areas covered at once. Again, in both scenarios, customers are looking for a managed service because of their own limited resources. They're looking for an OpEx spend versus a CapEx spend, and are usually driven to SD-WAN because they're trying to seek savings from their expensive private MPLS networks. Okay, so that's kind of the difference between the two types of offers and what's a good fit. Some of the common questions that we find customers asking is, what types of organizations benefit from migrating to this technology? And so, as I mentioned, we're seeing a really strong response in retail, where retail organizations have already begun to move away from private MPLS to public networks, but may be struggling with deploying the next wave, which would be their real-time applications. And we've had very strong interest in that area. Manufacturing is another one, particularly when you think a lot of manufacturing has rural locations that are expensive to deploy MPLS. SD-WAN and network as a service gives them a way to have consistent deployment of infrastructure and a high degree of security and reliability with using less expensive public network transport. Second question, is SD-WAN as solid as dedicated WAN? So solid could mean reliable, could be secure, could be as fast. So the answer is definitely yes, in terms of the fact that SD-WAN provides standards-based auto VPN so that the connections are secure. But it takes away the problem that existing VPN networks have had in terms of complexity of configuration. So, site-to-site VPN has been around a long time. Using SD-WAN makes that a lot simpler and allows for the same standards-based security using this technology. In terms of performance, the Cisco Meraki offer in particular allows for traffic shaping policies to be applied so that using the public infrastructure, you can carve out and protect the bandwidth by traffic type so that you can actually probably do more than you can in some cases with a traditional dedicated router, at least with by controlling the applications. Using existing router technology, you can do traffic shaping, but it's a lot more labor intensive and you have to touch every endpoint and can be very complex for most users. With SD-WAN, it's very simple. Then the third question, how does this work with my existing network assets? In most cases, deploying either network as a service or SD-WAN using VeloCloud, we can deploy that alongside existing network assets. So for example, let's say you have a larger location that has lots of switches and you want to deploy network as a service, but you don't want to refresh every piece of hardware. You can deploy network as a service kind of on the edge of your network and use that as a way to give you the visibility and control you need of the network without having to refresh all of the rest of the hardware in the environment. We also have options within the NAS offer that if you don't need the wireless access points or the PoE, that you can just deploy the MX Edge for security. Same with VeloCloud. VeloCloud, because it's focusing on those real-time applications, can in most cases be deployed alongside existing infrastructure to really focus in on the applications that you want to improve over the protection. But those are some of the common questions. Katie, did you have any other questions?
Yeah, Tim, we got one or two more. We were asked, how long does this take to implement versus a typical MPLS implementation?
Yeah, that's a great question. In your typical MPLS deployment, the time frames are extended, or the longest part of the time frame is usually waiting for that circuit to be installed. So particularly with fiber builds or difficult locations, there might be construction involved. Those deployment times can stretch months and months sometimes. With SD-WAN and VeloCloud, your deployment time frames shrink basically to almost about a time that it takes to have the public internet installed, the broadband service installed. Because with our deployments of both VeloCloud or Network as a Service, we are pre-configuring the information in the cloud even while we can ship the device. And so while it's in the air on its way to the customer location, that configuration can be built. The technician installs it, the device finds home, it downloads its own config, and it joins the network. So in most cases, we can shrink the deployment time into a few weeks.
Awesome, thanks. And the last question, are there any connectivity requirements as it relates to an SD-WAN or a Meraki type of managed service?
Generally speaking, no. At minimum, we're going to have probably an Ethernet-based service of some type. So that can be DSL, that can be cable, that can be fiber, that can be T1, handed off as converted to Ethernet using a router. It can be a USB 4G modem. So both of these platforms are pretty transport agnostic, and we're confident we can follow up and work with you to find a way to deploy this in almost any kind of situation. And those can be private MPLS connections in combination with public connections as well. It doesn't have to be one network type or the other.
Thanks, Tim. And I think that's all the time we have for questions today. So thank you, everybody, for joining us. And we will have another meeting soon. Thanks. Bye-bye.